Okay, so up until this point, we've been able to sketch a parabola very well. We know the parent function and we know how to shift the parent function. We know how to find x and y intercepts. This chapter, we are going to get sort of into the nitty gritty of parabolas. There's going to be a lot of different formulas to memorize for the different parts of a parabola, and that's why I don't really love this chapter. So we'll get through it though. It'll be fine. So what we want to do is, if we have a parabola or a quadratic in the form of y equals ax squared plus bx plus c. So this is the standard form of a quadratic, ax squared plus bx plus c. And when we have a quadratic like this, we know how to factor it, usually, right? Or use the quadratic equation. But do you all recognize that this is a parabola? How do you know it's a parabola? Dylan? Because of the x squared, okay? Because it's in the parabola format in ax squared plus bx plus c. But if we were to look at this, would we know where to shift it or how to shift it left, right, up, down when it's in this format? No. So we're going to take a quadratic in standard form and change it to vertex form. So we're going to take a quadratic in standard form and change it to vertex form. And what do I mean when we change it into vertex form? It means we want it to look like y equals a times x minus h squared plus k. So this is our standard form. This is our vertex form. All right, so then how do we take a quadratic in standard form and change it to vertex form? We complete the square. That's how we do that. So let me show you what I mean. So let's say I have y equals x squared plus 2x plus 1, and I want to convert it to vertex form. Now, we know how to solve a quadratic by completing the square, right? When we're solving a quadratic by completing the square, we usually take the quadratic, we set it equal to 0, and don't we move all the loose numbers or the constant terms to the other side? Right, but we're not going to do that now because we actually want the constant to stay, because what's our constant end up becoming? Our k. So we're not going to set it equal to 0 like we're solving. We're not going to move the constant or the loose number to the other side. So we're going to sort of just leave it as it is, and I'll tell you how we still go about doing this properly. So we're going to have y is equal. We're on a delay here. That's not good. So we have y is equal. Then what I'm going to do is I'm going to group my x terms together. So we're going to have x squared plus 2x. I'm going to leave a little bit of room and close my parenthesis. And then I'm going to do that plus 1. I'm going to leave the constant on the outside of the parenthesis. So now what we're going to do is we're going to complete the square within the parenthesis. So what do? I go to my x term. Who remembers? What do I do to the coefficient of the x term? David? First, divide by 2, then not double it, square it. So we're going to take our x coefficient, we're going to divide it by 2 or take half of it. What's half of 2? 1. Then what are we going to do? We're going to square it. What is 1 squared? So I'm going to add 1 inside my parenthesis. But now I still can't change, really, I can't change the value of this quadratic equation. So by me just adding 1 in this quadratic equation, am I changing the value? Absolutely. What's the only way to keep this balanced? If I add 1 to then do what? Subtract 1. But now I'm going to subtract 1 outside of my parenthesis to keep this balanced, all on the same side. So now inside the parenthesis, what we should end up with is a perfect square trinomial. Meaning if I factor what's inside this parenthesis, I should be able to get some binomial raised to the second power. And if I factor x squared plus 2x plus 1, what is that factored? X plus 1 squared, the quantity of x plus 1 squared. And then outside my parenthesis, I have a plus 1 and then a minus 1, positive 1, negative 1. What happens to that? They cancel. So what would my k be here? Really, wouldn't it be plus 0? My k would be 0. So would we know how to shift this parabola? So my parent function is centered at or turning point 0, 0. Where would I shift? I would shift 1 unit to the left and 1 unit up or down, or nothing at all? Nothing at all, because my k is 0. So we just shift 1 unit to the left. I would have my x-intercept that 1 unit to the left. Wouldn't my x-intercept be negative 1? Would there be a y-intercept? Yes, no, maybe so. Visualize it. Will there be a y-intercept? Absolutely, there's going to be a y-intercept. Would we know right now off the bat? No. Would we be able to find the y-intercept? Absolutely. This should have 2 roots, right? Because it's a quadratic, it should have 2 roots. How many roots do I have, though? I only have 1 root. Why? It is a double root. Good job, Aaron. That is a double root. What does it mean to be a double root? It bounces back up. It means it hits the root. It doesn't go through the root. So it hits the root, bounces back up. So that negative 1, that root negative, that equals negative 1, that counts twice. That counts as our 2 roots because it hits it and then bounces back up instead of hitting it and going straight through, then coming up. That's the double root. Okay. You guys try this one. I want you to convert from standard form to vertex form. Actually, I'm sorry, I'm going to change this. Guys, don't be so mad. You're all huffing and puffing. You're fine. That's why we have pencils. How have we done so far? Are we still working? Who needs another minute? We need another minute?
Did you finish your math notebook too?
All right, let's go through this. So when we're solving, hush children, when we're solving when we solve by completing the square, we generally set the quadratic equal to 0 and move the constant to the other side. But when we're just trying to convert from standard form to vertex form, do I do that? Do I move the constant? Do I set it equal to 0 and move the constant to the other side? No, we don't do that. So what are we going to do? We're going to leave everything as it is, but I'm going to group together the variables. Then I'm going to leave the constant on the outside. Take half your x coefficient. What's my x coefficient? Yeah, so we're going to take half of 4. 4 is 2, 2, and then square it. 2 squared is 4. So now I'm adding a positive 4 inside the parentheses. But to maintain the integrity of the equation and not change its value, what do I have to do outside the parentheses? Subtract 4. So now what ends up in the parentheses should be a perfect square trinomial, which means when I factor it, I get some quantity squared. What is going to be my quantity that's going to be squared? X minus 2. And then on the outside, I have a positive 3 and a negative 4. Do we agree that's a negative 1? So now think, we have our parent function where the turning point is centered at 0, 0. Where am I shifting this parent function? Dylan? 2 to the right and 1 down. You'll have 2 x-intercepts. Will you still have a y-intercept? Yes. Absolutely, you will have a y-intercept. Okay, so now let's see what happens when you have a leading coefficient. What do we do when we have a leading coefficient? So if I have y is equal to 2x squared minus 4x plus 3.
Divide by 2, right?
You got it. Okay, but I'm not going to divide everything by 2. So what I'm going to do to make this a little bit simpler, I'm going to group together. I'm going to do what I did before. I'm going to group together my x terms. And then I'm going to pull out a leading coefficient. Just stay with me. So when I pull out the leading coefficient, which is 2, I end up with x squared minus 2x. I'm going to leave some space and then still plus 3 on the outside. Now I'm going to complete the square inside the parentheses. Half of 2 is 1. 1 squared is 1. Be careful now. When I go to add or subtract something outside the parentheses, I'm not going to subtract a 1. Because technically, this number is not 1. What is this number? Technically, this number is 2 times 1, which is 2. So when I go to the outside to keep this balanced, I'm not going to subtract a 1. What am I going to subtract? A 2. So now I'm going to have 2 times the quantity, and I'm going to factor inside the parentheses, x minus 1 squared plus 1. All right, we're going to do a few problems. All right, so now I'm going to have us convert y equals negative x squared plus 5x plus 2. I don't want my leading coefficient to be negative. I do not want my leading coefficient to be negative. So I'm going to group together the x's, and then what am I going to pull out? A negative 1. And then I'll have x squared minus 5x, leave some space, close my parentheses, plus 2. So now I'm going to go to my leading coefficient, I'm sorry, not my leading coefficient, the coefficient of my x term. The coefficient of my x term is 5. I'm going to take half of 5, and I'm going to leave it as a fraction. Half of 5, isn't that 5 halves? Right? I'm going to leave it as a fraction, because then what am I going to do with this fraction? I need to not subtract it, square it. And that's why I left it as a fraction and not a decimal. It's easier to square a fraction than it is to square a decimal. So you all could have changed that to 2.5, but that's not good. It's easier to square a fraction than it is to square a decimal. So then when I square this fraction, 5 over 2 squared, isn't that 25 over 4? So then inside my parentheses, I'm going to add 25 over 4. But be careful. Technically, this is not a 25 over 4, right? Isn't it negative 1 times 25 over 4, which is a negative 25 over 4. So to keep this balanced, this is really subtracting 25 over 4. So to keep the integrity of my equation, on the outside of the parentheses, I'm not going to subtract the 25 over 4. I'm going to add a 25 over 4. I want it fractions. Okay, so here we're going to have y is equal to the negation, and now I'm going to factor this. Guys, just so you know, when you come to factor a perfect square trinomial, all you're really doing is just taking the square root of that last term. That's all you're doing. You're just taking the square root of that last term. So it's going to be x minus the square root of 25 over 4. Isn't that 5/2? And now on the outside of the parentheses, what I want you to do is create a common denominator. On the outside of the parentheses, I want you to create a common denominator. So we are going to be 8 over 4 plus 25 over 4. So we're going to have y equals the negation of x minus 5/2 squared plus 33 over 4. Aditya, why was your hand up? Your hand was up. Okay, sure. Okay, next one. So now I'm going to shake things up a bit. What's different? The x's and y's are switched. Isn't it usually y equals some x quantity squared plus blah, 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 right? X's and y's are switched. What does that mean? This does not represent a parabola. It represents its inverse. What does an inverse parabola look like? A parabola on its side. Very good. It's a parabola on its side. It's still a parabola, but it's a parabola on its side. Okay, it is the inverse. Okay, so what are we going to do? Well, first, I don't want that 5 there, but I'm going to leave it for now. We will eventually get rid of the 5. Ultimately, we needed x equals something over here. But before I get rid of the 5, I want to do my work on the y squared plus 4y minus 26. I want to complete that square. So what we're going to do is we're going to group together the y's. So we're going to have 5x is equal to y squared plus 4y, leave that negative 26 on the outside. Half of 4 is 2, 2 squared is 4. Now, what do I do outside the parentheses? Subtract 4, you got it. So now I'm going to have 5x is equal to the quantity of y plus 2 squared minus 30. Okay, now what I'm going to do is now I'm not done because it has to be just one variable by itself equals everything else. So I'm going to go ahead and I'm going to divide that 5x under everything. I'm going to divide, not the 5x, the 5, sorry. I'm going to divide the 5 under everything. So now we're going to have x equals, stay with me for a second because later on this will matter how we write this or make it easier if we write it the correct way. So we have the quantity of y plus 2 squared divided by 5. Dividing this quantity by 5 is the same as multiplying it by what? Good, Aaron. It's the same as multiplying it by 1/5. I'm going to choose to write it as 1/5 times the quantity of y plus 2 squared. Why do you think I chose to write it as 1/5 times this quantity versus this quantity divided by 5? Why do you, even though they're the same thing, why have I chosen this bottom to write it as the bottom way versus the top way? Ryan? You got it. That way, this way, we recognize what A is. What is our A here? 1/5. Okay, that's why we are now assigning A as a number. Hey, minus, and then 30 divided by 5 is 6. All right, next one. Okay, so now, guys, you're being so rude to me. All right, so now what we're going to do is the same thing we did before. Don't get scared of the fraction. Don't let it intimidate you. We're going to group this together. What am I pulling out as a GCF? Negative 1/3. So I have f of x is equal to negative 1/3. Obviously, the negative 1/3 will cancel. But now, when we pull out a GCF, what operation are we doing? Division. So what is happening with this negative 2? This is negative 2 divided by negative 1/3. Do we agree? When we pull out that negative 1/3, it's negative 2 divided by negative 1/3. Keep, change, flip, right? So negative 2 times negative 3. What's negative 2 times negative 3? Positive 6. So we're going to have x squared plus 6x. Leave some space, close your parentheses, then plus 1. Half of 6 is 3. 3 squared is 9. So we're going to add 9 to the outside. But what am I doing? Sorry, 9 to the inside. What am I doing to the outside? Subtracting 3? Adding 3. Why, Dylan, is it adding, not subtracting? Because it's a negative. You got it. So now I'm going to have f of x is equal to negative 1/3 times the quantity of x plus 3 squared plus 4. All right, somebody explain to me visually how this parabola would look. Just like a rough sketch of what would be happening here. Matt? And is it smiling? Is it frowning? I'm sorry? It's frowning. You got it. It's facing down. You got it. We're going to talk more about that nitty-gritty stuff in a bit. Let me have you try one on your own, and then we'll move on. Okay, here we go. All right, you all do this one. All right, who has an answer or a format for me? Tejas?
X equals 1/6 times y minus 3 squared plus 5.
Plus 5? How many people got that? Good job. Anybody want to see me do it? Is this a sideways parabola or is this a vertical parabola? Sideways. How do you know it's sideways and not vertical? Good. It's x equals. You got it. Okay, so now we're going to get into some nitty-gritty of a parabola. It's really day 2 where we get into the real nitty-gritty of a parabola, which is the worst. But this today is still not bad. No, this is still day 1. This is still day 1. Okay, so we know if A is greater than 0, then we're opening up. If A is less than 0, then we are opening down. All right. Couple more things we need to talk about. Let's say I'm not going to center it at 0, 0. All right, so my hand's a little shaky, so I'm not getting it completely accurate, but you all get the gist. Okay, so what do we need to know? The turning point where everything shifts. So right now, it's like going down, going down, going down, hit that turning point, going up, going up, going up, right? That's our turning point. It's also called the vertex. So this is the vertex. And our vertex is always HK. That little dashed line I just drew, does anybody know what that's called? Claire? Good. This is called the line of symmetry, or sometimes the axis of symmetry. Right, and this is going to be an equation of a line, right? Our axis of symmetry is always a line. What, for this specific parabola, what is our axis of symmetry? What kind of line? A vertical line. Is a vertical line x equals or y equals? X equals whatever the x-intercept is. Isn't our x-intercept here h? So it's x equals h. All right, so x-intercept, set y equal to 0. Y-intercept, what do? Set x equals 0. Then solve. then solve. All right, so that's for our vertical parabola. Now let's talk about our horizontal parabola.
We can talk about that tomorrow, right?
No, still today.
Yeah. Daylight savings time.
X equals a times y minus k squared plus h. So, in terms of our equation, a couple of things have shifted, right? Our a is still our a, still in front, right? Instead of y equals, it's now x equals. And then what else has changed? Our h and our k have switched locations. Our h and our k have switched locations. So, this time, if a is greater than 0, then we're opening to the right. If a is less than 0, then we are opening to the left. Okay, so now our turning point, do you see this is going here, hits this point, and then it turns back around, right? So that turning point is called the vertex, which is still going to be h comma k. That turning point is the vertex, which is still h comma k. Ooh. This is not good. Hold on. I didn't draw this properly, sorry. There we go. That's better. Is that better? I think it's better. Nope, still didn't draw properly. There we go. Now that's better. Okay. What is this line? What is this line? The axis of symmetry. This is the axis of symmetry. And now this axis of symmetry, is it a vertical line or a horizontal line? Horizontal. So is it x equals or y equals? Y equals, and it's going to be y equals k. Y equals k. And it's going to be the same idea as before. The x-intercept, set y equal to 0, then solve. Y-intercept, set x equal to 0, then solve. Same thing. X and y intercepts are the same thing. Okay, so now this is very similar to what I'm going to ask you on the homework. So I'm going to give you an equation, y equals 1/8 x squared, something like that. This is actually number 2 from your worksheet. Number 2 from worksheet. All right, and I'm going to ask you a couple of questions. I'm going to ask you to identify the vertex. I'm going to ask you the axis of symmetry. I'm going to ask you the direction. I'm going to ask you the x-intercept, and I'm going to ask you the y-intercept. So I'm going to ask all 5 of those. Right. Yes. All right. So it's going to be even worse on the test. So now, so now what we're going to do is I'm going to put this in vertex form, even though there's not really much to manipulate. This 1/8 is my A. Do we all agree that 1/8 is our A? Then I'm going to open up my parentheses. X squared, isn't that the same as x minus 0 squared? Plus, what is my K? 0. So it's 1/8 times the quantity of x minus 0 squared plus 0. So this fits the format of, sorry, this is y equals this whole thing. So this fits the format of y equals a times the quantity of x minus h squared plus k. My a is 1/8. My h is 0. What's k? 0. Well, according to what I just told you before, our vertex, isn't it h comma k? So what's our vertex here? 0, 0. Now, our axis of symmetry, as I told you on the last page, our axis of symmetry, because this is a vertical parabola, our axis of symmetry will be a vertical line, which is going to be x equals h. Well, didn't we just say h was 0? So our axis of symmetry is x equals 0. Am I going too fast, or are you all following along with how I'm getting all this? David?
Wait, why would it be x equals 0, not y equals 0? Oh, no, I see why. The x.
Okay, direction. Are we opening up, down, left, or right? Up, because our A is positive, we are opening up. All right, now we go x-intercept. I don't need to do any work for this. If you can visualize this, you will know what it is. What is our x-intercept? 0, yeah. What is our y-intercept? 0. Let's say you didn't know. Let's say you couldn't visualize it. You do y-intercept and you would say y equals 1/8 x squared. You'd set x equal to 0. So y equals 1/8 0 squared, which is just 0. So my y-intercept is 0, 0. And let's say you still didn't know and you needed to find the x-intercept. You would do 0 equals 1/8 x squared, multiply by 8 on both sides. You would get 0 equals x squared. So once again, x is equal to 0. So this is 0, 0 for our x-intercept and our y-intercept. Yes. Yes. Sure. Like there? We're not done. We're done with day 1. No, we're not ending.
I didn't know we were starting to I tried that.
Are we ready? Dylan, did you write it all done? Yes.
How many units are like in the whole entire year?
17 maybe?
Oh, okay.
I don't really know. Okay, so this is, Dylan, you got it all? Okay, so now we are going to Unit 12, Day 2. We are getting into the nitty-gritty. All day, everyday parabolas. So we're gonna go, I don't like this day. So my goal is to end on a test for spring break. So this is why I'm doing this. So then you don't get it the day after spring break. I don't know. All right. So parabolas, definition, the true definition of a parabola is the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix.
Can you go on a little bit? I didn't get the last part.
Yeah.
There we go. These are cute questions. Okay, I was gonna put you through this.
There we go. All right. And label some things here. I'm going to call this C. I'll call this B. I'm going to make this a little bit bigger. There we go. Okay. So I'm going to call this C, this B, this A, all right, you guys draw this. I'm going to explain some things to you. So this is our parabola. So remember the definition. The definition says a parabola is the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix, right? Here's our vertex, right? We're going to say the directrix. I shifted this. That's okay. I didn't want it on the x-axis, but it's okay. So let's say this, what I'm highlighting in pink, line, is the directrix. This point right here that I just pointed out, what is that called? The vertex. And this green point is going to be the focus. I messed this up. I don't know why these graphs always mess with my vision. I think it's my old eyes. Everything seems blurry to me. Sorry. These online graphs are no good for my eyes. There we go. I just shifted it all. Okay, so here's our graph. What this is, there's my focus, there's my directrix. My focus is a point, my directrix is a line. Every single point on this parabola will be the same distance to the focus as it is to the directrix. They'll all be an equidistant from them. So every point on the parabola will be the same distance to the focus as it is to the directrix. So what does that mean? So from here to here will be equal to there to there, right? Our vertex will be the same distance to the focus as it is to the directrix. Every single point on the line will be the same distance to the focus as it is to the directrix. That's really the main thing you need to know about those two vocabulary words. All right, next vocabulary word. Latus rectum. Get your giggles out. Okay. A line segment through the focus perpendicular to the axis of symmetry the endpoints are always on the parabola. Write it down and then we'll go back up to our graph. Are we ready? Can I go back up, Dylan?
Yeah.
Okay. So going back to here, so do we all agree, let me highlight in yellow, this yellow line is our axis of symmetry? Okay, so our latus rectum is going to go through the focus, be perpendicular to the axis of symmetry, but its endpoints have to be on the parabola. So if I have to go through this focus, this green point, and I also have to be perpendicular to my axis of symmetry, well, what kind of line will be perpendicular to a vertical line? A horizontal line, right? So now I need to draw a horizontal line through my focus that is perpendicular to the axis of symmetry, and that is our latus rectum. All right, this is where we're going to stop. All right, your homework is a worksheet from